Hi, Algebra 1 students. This is Mrs. Richart. Today we're going to look at how to create dot plots and box and whisker plots. You might have learned this in previous classes, but we're going to go ahead and review that today, and then we will learn how to interpret them and compare them later this week. So what is the difference? Here's an example on the left of a dot plot, and then an example of a box and whisker plot on the right. So what is a dot plot? A dot plot is a number line used to represent data by stacking X's or dots above the numbers. So let's create one. So 12 employees at a small company make the following annual salaries in thousands of dollars. So for example, 30 is $30,000, 45 is $45,000. Create and label a dot plot. We always want to start with a number line. And I see my lowest value is 25 and your highest is 60. If they're not arranged in order, you'll want to go ahead and do that. Because I'm looking at 25 to 60, I might want to go a little bit past both of those. So I'm going to label my dot plot with the title salary, thousands of dollars, and then I'm going to go ahead and list the values 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, and 70. If you notice, all of the values that we have are in increments of 5, and so I went a little bit lower and a little bit higher. We need to make a dot or an X for each data point. So if I put a dot on 25, I can cross that out. A dot on 30, I can cross that out. I have 3 35s, so I'm going to stack them vertically, cross them out. I have 3 40s. I'm going to stack them vertically and cross them out. I have 2 45s, 1 50, and 1 60. If you notice, I can see that I have 12 data points because I have 12 dots. I also can see that the mode salaries are 35,000 and 40,000. You can calculate mean, median, and mode, and of course the quartiles and the interquartile range and range, doing exactly what we have been doing, either using the dots or the data points. So now we're going to look at what is an outlier. So remember, it's a number much bigger or much smaller than the rest, and it greatly affects the mean and range. So we use the median to represent a data set when we're looking at measures of center if we have an outlier because the mean is greatly affected by that. So using our previous example, suppose that the list of salaries from the company used in the previous example is expanded to include the owner's salary of $150,000. Now the list looks like this. The corresponding data plot, the dot plot, looks like this. Of course, the owner is going to make much more than all of the regular employees. If you look at it, there is a calculation to figure out outliers. We're going to figure this out by just looking at it. This value right here, $150,000, appears to be an outlier because it is so much larger than the rest of the values. We're going to move on to looking at a box and whisker plot. It gets its name because it looks like a box with 2 whiskers. It is a diagram showing quartiles 1, 2, and 3, where the data can be split into quarters, or quartiles, in a box with lines extending to the lowest and highest values. Here is an example. We have a box with a whisker on each side. We have the lowest value, Q1, Q2, and Q3 are our quartiles, and our highest value. Q2 is also representative of our median. So how can we create a box plot? For this example, the worldwide grosses in millions of dollars for the top 10 highest grossing films of all time are given. Create and label a box plot of the data. So these are millions of dollars for movies. So we're going to start similarly to the dot plot by making a number line. I'm going to list increments of 200, and that's just what I chose. As long as you have a little bit lower and a little bit higher than your lowest and highest values, you're good to go. You also want to always have a title, film revenue in millions of dollars. We're going to start by finding the minimum and the maximum. The minimum, we have 1215. So I'm going to take that minimum and put a dot on the number line. Then I'm going to look at the maximum, which is 2788. I have my maximum, I'm going to put a dot on the number line. So now to finish our box and whisker plot, we need the median and then quartile 1 and quartile 3. To find our median, we're going to do what we did last time, making sure all of our data points are in order from lowest to highest. Now we're going to cross them out. So going from the outside in, I notice I have two middle values. So to find the median, when we have two middle values, we find the average of the two. So we add them up and divide by 2, which gives us a median of 1518. And median and quartile 2 are the same thing. So I'm going to go ahead and put a vertical line at 1518. Now I'm going to find the median of the lower half and the median of the upper half. So the median of the lower half, if we continue to cross things out, we use 1516 since we didn't use that for the median. So I'm going to cross out 2 at a time until I get to the center, which is 1342. 1342 is our quartile 1, and I'm going to put a vertical line there. Then we're going to do the same thing on the upper half. So I'm using 1520 since I didn't use that. It's not the median. Crossing out. Our middle of the upper half is 2060. That's our Q3. I'm going to add that to my number line by putting a vertical line. To finish off our box plot, we have a box, and then we extend the whiskers to both sides. This is the box and whisker plot we just created. You can see we have a 5-number summary of the minimum, quartile 1, median or quartile 2, quartile 3, and maximum. They are all in quartiles where 25% of the data is between the minimum and quartile 1, 25% of the data is between Q1 and the median or Q2, 25% is in Q2 to Q3, and 25% is in Q3 to the maximum. The middle 50% of the data lies right where the box is. So if we look at just that box, that is our IQR, in a quartile range. And then from the minimum to the maximum is our regular range. If we look at another example, the average age at which women first get married differs by country. The ages for 8 countries are shown. Using Desmos or by hand, you can calculate the 5-number summary: minimum, quartile 1, median, quartile 3, and maximum. Here's a multiple choice question. Choose the correct box plot for the data. As you can see, A, B, and C have the correct minimum and maximum. The letter D doesn't have the minimum and maximum, it just has the box, no whiskers. Looking at the median, it's 26.5. So when I look at that, I see that letter B is the best choice. If I zoom in on the box plot of letter B, I have this. We're going to answer a couple questions first. So if we were just given the box plot above, could you determine the mean of the data set? Remember that line in the middle represents median. So no, only the median, not the mean. It's because looking at the box plot, I have no actual data values. I don't know any of the data values except for the 5 that are listed there. And they might not even be data values because the median lies in between 2 numbers. What is the IQR of the data set? Well, looking at that box, we have 30 minus 23, which gives us an IQR of 7. What is the range of the data set? Taking the maximum value of 31 and subtracting the minimum of 20, I get a range of 11. What percentage of women get married before they are 23? So I'm looking at 23, and that's my quartile 1. So before, if it's represented and split up into quarters, that's 25% of women, on average in all the 8 countries, get married before they are 23. 50% of women get married when they are older than what age? Well, this is the upper 50% of the data. So looking at this median or quartile 2, I have 26.5 years old. If you have any questions, please contact your teacher and go ahead and complete today's practice. Good luck.